those have been identified as highly energetic thermatic materials. And if you could actually just pan over here for a second.
Yeah, come on.
Over here what we have are some of the red-gray chips. Over here, these are from 4 different samples. This is using a X-ray microscope to kind of look at the red-gray, the boundaries here. They broke a chip so that they could get a good look at what the material is here. And then by using X-ray energy dispersive spectroscopy, what you're able to do then is identify what the materials are that are in this red layer here. And you can see there's a lot of carbon. There's oxygen, aluminum, and silicon. And those are the primary components of thermite or thermate. And these are from the 4 different samples, showing that they basically have the same characteristics. And if you take a look at what this material, what thermite is, for example, is what they use to CAD weld electric or rails together, railroads, so you have continuously welded. You put the rails together, you put the powder there, you ignite it by heating it up, and once it starts to react, it's iron oxide and aluminum. You heat it up enough, the aluminum will grab the oxygen off of the iron oxide, leaving you with elemental iron, and the aluminum oxide is a white smoke that goes off, and so you have this reaction that creates iron, and the temperature of the iron will be about 4,500 degrees. You need that's about 2,000 degrees more than you need to melt steel.
So you can make the 2 metals flow, and the rail becomes a monorail.
That's right. That's how that works, and because it welds it all together. Yep. Okay, so you've got all the elements here of this stuff called thermite, and so if you take these red-gray chips and you say, well, if it is thermite, how energetic is it, right? And so what we have here is we put the material in a differential scanning calorimeter. Now, a differential scanning calorimeter is where you take a little piece of the material, you stick it in this thing, and then you put a known amount of heat. And as you put a known amount of heat into it, it'll heat up and it'll get hotter. And if it gets hotter than the amount of energy you put in, it's reacting internally itself. Mm-hmm. And so if you take a look at the red line here, this is the best published paper on nanothermite, and it was published by Tillotson in 2001. And it shows that by the time you heat it up to about 480 degrees centigrade, it begins to react. And once it begins to react, by the time you get up to 560 degrees, it's completely reacted. Mm-hmm. So that's what this red line is. If you take the red-gray chips and you put it in this differential scanning calorimeter, what happens is at about 400 degrees, 420 degrees centigrade, it becomes much more reactive, and you can see it's much more energetic, much more spiky, which means it's almost explosive. The authors of the paper haven't said that it is by itself an explosive, but just that it's highly energetic. And what is this material doing there, right? So the upshot of having this here is that you'll end up with liquid iron, elemental iron, aluminum oxide, smoke, and that if it is explosive, you'll see this iron being exploded out into the air. And then it'll cool in the air as these tiny iron spheres. And if you take a look at the dust, the World Trade Center dust, it's between 0.1 and 2% tiny iron spheres. And as a result of of this interaction here, creating these spheres, those were the identifiers for when they were doing the cleanup as to whether they found World Trade Center dust or dirt. If they found those iron spheres, it was World Trade Center dust. So it's a well-known, well-documented component of the World Trade Center dust, but nobody has identified a source for it. People have said, oh, gee, well, maybe it's just welding rod left over, when they welded the buildings. First of all, there's not that much.
And also different chemical composition compared to welding rod or whatever. The other thing, the spheres, because let's see, once I get the iron to the molten point, if I put it in the atmosphere, then surface tension will make a sphere.
That's right, yeah.
Just like any water and when atomizing. Yeah.
Right. So this is one of the characteristics of the dust that that people have asked NIST about, and NIST says, well, here's what NIST says: There's aluminum. Well, there's iron and there's rust and oxygen.
And there was aluminum in the plane. Yeah,
and there's aluminum in the plane, and these are like you have this stuff all over the place, right? So in other words, they can't tell the difference between what this is and a bud, a rusty pipe and a can of Bud. Budweiser can. So even though this is highly energetic, the other thing I probably should have mentioned here is that because the reason this is much more energetic is the atomic spacing between the elements in this is much closer than in the Tillerson paper. That's why it would be much more reactive, much smaller distances. And so it has to be a much more highly intermixed, highly engineered process to put all this stuff together.
And this is where they found that it's very similar to what's known as nanothermite?
Yes, well, this is this red
And
trace
you
here
go
is
to,
nanothermite.
just similar to the anthrax attacks after 9/11, you go and you look at it, who are the capabilities or who utilizes or who has access to the machines that can make.
Yeah.
And it's not guys in caves,
Right.
to the best of your knowledge.
It's not, I have no comment on
Guys
it,
and
but
caves.
but I suspect that you've made a very good point.
Well, that, when you look at different things and you say, well, gee, there's only certain places on the earth where you can produce that effect of getting it down that small. Yeah.
Right. So anyway, it's a highly engineered product that has no reason for having been found in the dust. The
location.
hypothesis is that this is part of the material that would have been used to weaken the buildings and potentially allow other much less powerful explosives to completely destroy it. I don't know everything about the explosives, but when it comes to the Twin Towers, you can see that they're exploded outwards, as you had pointed out earlier. Instead of finding 110 pancakes down at the bottom, hitting floor after floor after floor within the confines of the outer perimeter sections, you see 95% of the mass is exploded outside the building, and there's a 3D model over on the table here that maybe you can
I have imaged.
and I think that would be very useful to kind of take a look at where the footprint of all the material is, and that's that's a pretty accurate representation based on photographs in 3D, some really nifty 3D mechanical model building technology.
There was another building besides the two Twin Towers that collapsed on 9/11. Building 7, I notice you have a panel here and you're showing what looks like the sequential collapse of this 47-story building.
Oh, yes. And so what we have here is
Excuse me.
basically some scenes here. Building 7 was not hit by an airplane. It had some small fires, and it collapsed at 5:20 in the afternoon. And you can see that it's coming down nice and smooth, symmetrically, right? And so the speed here of the wall, the roof line coming down, has been analyzed. And if you were to take a look at if you were to put a red dot at every equal time increment, you'll see that the spacing is getting further and further and further apart, indicating that in the same amount of time it's gone further.
Greater distance.
So that's the difference. The distance can be translated to speed, and the increasing speed can be translated to acceleration. Now, if you go over here and you plot velocity versus time, you can see that the velocity is increasing at a continuous rate for a time period here. If you were to take a cannonball like Galileo did and dropped it off the Tower of Pisa, it'll go down. Nothing's holding it up. It will accelerate at 32 feet per second squared, right?
Exactly.
Per second. And that would represent the solid green line. If you actually plot the little red dots here, you'll end up with something that approaches it very carefully for about 105 feet. And NIST has actually even agreed to this, that was in free fall for 105 feet, 8 stories. And the only way that the cannonball can accelerate at 32 feet per second is if there's nothing holding it up and it's in free fall. And that means if this is accelerating at the same speed, then nothing's holding up the roof line. And the only way to get the entire roof line to collapse simultaneously is if, at that free fall rate, is if there's nothing holding it up. And then you can see that after about 8 stories, it starts to, the acceleration basically slows down dramatically, as you can see by this going off to the right-hand side. And what that, it's beginning to impact other structure material down below. And so it's no longer able to be in free fall, and it's more or less a constant velocity.
And I'm just checking, I'm going to change this. This is the same building that was housing the largest CIA facility outside of Langley, Virginia, yes?
Well,
You may not know. For the viewer may want to check that. The other thing the viewer may want to know is the other tenants were mostly federal government, Department of Defense. Also the SEC. I believe they stored the records of Enron, which was the greatest bankruptcy up to that point, and also WorldCom, exactly.
Right.
The interesting thing was Rudy Giuliani, that would-be presidential candidate, also had his command bunker supposedly in said building, building number 7, the one not struck by a plane. Yet it fell into its own footprint.
Also, 88, it had been
Oh, it had been strengthened, and also didn't it sit on top of the power the power station, the substation, and you had the, they had to strengthen anyway because all those buildings were sitting on, if I remember World Trade, I used to get off at that stop. So subcontaneous to all this stuff, or under it anyway, was the, what do they call that wonderful tube system? The subway.
Subway, right.
Yeah.
So,
Interesting.
so this is a classic Newtonian physics. How do you explain this any other way? NIST actually has documented this and said, well, they've got this three-phase approach. They tend to measure time from some point over here to some point over here, and said, well, there's no free fall because, well, even though they show that it is in free fall for a short, they don't do anything with it. They don't change their hypothesis. Now, let me tell you what that's like. That's like going to the local coroner, and the coroner says, son, I really hate to tell you this, this really a real tragedy about your pappy having that massive heart attack. And in his hands, he's got the autopsy report that says knife wound.
I was going to say hit by a car.
Knife wound right through the heart. And that's what the autopsy report says. At his age, imagine that. What a tragedy. I mean, that's what it's like. You've got the evidence that there's a knife wound, and yet he's saying, oh, damn, heart attack, really bad. Sorry, feel bad for you. In fact, this should have been something that would send a legitimate study back to square one and say, well, how do we explain this? And
I always go with the Latin thing, cui bono, who benefits? You look at what happens and you say to yourself, as a person who tested weapon systems, I'm like, gee, the cave thing didn't work for me.
Yep.
Okay, and then I'm like, well, who's gonna benefit from this? Right. And do I see a bunch of people on the other side of the globe that have resources benefiting? No. Yeah. Didn't see it. Well, yet. Maybe they got to sell me harder.
Well,
one other thing, just because you had mentioned this right off the beginning, and you said the demonization of certain types, and I think of the class of what they're looking to produce is probably a clash of civilizations. But also for the viewers, have you not recognized over the past 10 years the demonization of anyone who asks questions in regards to whether it's the physics of 9/11, okay, the funding of stuff, the people, the reports, all the stuff that they come out and they have to keep on backpedaling and saying, well, gee, no phone calls came from those planes, so the let's roll thing didn't work. But the demonization, once again, of what are known as truthers. Right. And I'm so happy that every now and then I get to be with truthers.
Well,
instead of liars.
I was just going to use that word. Yeah. I much prefer being called a truther than a liar, right? Because I believe that the physics is really hard to argue against. And partly in response to the question about the demonization of the derogatory use of the word truther, I've begun to use the word engineering ethics. What we're in fact doing here is talking about engineering ethics and calling a fraudulent engineering report fraudulent and standing up for engineering ethics, which I think is very important. You wouldn't want a fraudulent engineering report, for example, about the nuclear plant disaster in Fukushima, simply because you want to understand what happened, what can go wrong, where did they miss it, and potentially by extension, what else could go wrong that you didn't think about.
And do we need to address anything with other similar built systems?
That's right, but you don't want, the key point is you don't want a fraudulent engineering report saying, oh no, everything was fine, but we had this one little thing that went wrong, and it was no one's fault, right? And there's no corrective measures. I mean, you don't want that. You want you expect
I
that when you
know.
get an engineering report, you get an assessment of what actually happened that's demonstrable and physically accurate. And what we have with the NIST reports is something that's fraudulent, and it's an affront to me as an engineer.